Hello. Can someone test the audio? Say hi or something?
Hello, everyone. Can you hear me?
Yes.
Excellent. Hi, Jaime.
Hello, everyone.
So maybe just 1 or 2 minutes. Pascal is here, so he'll be showing the slides. Let's start.
I updated the slides a little bit, actually.
Okay. Let me see. Did you upload the slides to the data tracker or?
Not yet. Can you send me the link? Sorry for that.
Yep, or you can send me the file and I'll do that right away for you.
So I will present the slides. We will be starting in a minute.
You should have them now, Alex.
Yes, I'm just uploading them.
So this is an official interim for the SCHC working group. Well, as usual, we'll be showing the intro slides and in particular the net well. So you're aware, I'm sure, of the patent rules at the IETF. So if you're aware of a new proposal which is subject to IPR, then please announce this IPR or refrain from discussing these new ideas. And you know that the IETF is very sensitive to code of conduct and how people behave during those meetings. So please behave. And if you're aware of any form of harassment, then you may contact the Ombuds team. The link is given here. And the agenda for today is 3 pieces. And yes, I guess Reim's slides will be uploaded soon. So we'll start with SCHC for ZD devices. So it's going to be Edgar. And then tokenizer-based compression, and then we'll have a discussion on the SCHC architecture concepts and some ideas that Carles and I have worked together. And so with this, maybe since it's already time, we can move directly to Edgar. Edgar, are you ready? Do you want me to throw you to present your slides?
I did some minor changes, so if it's okay that I share my screen.
Okay, please go ahead.
Okay.
So I should to grant you the screen. So it's
Okay.
It's waiting for your slides.
Let's see. Okay. Can you see?
Not yet. It says that the share is being started,
Okay.
but
Let's see.
I'm not seeing it yet.
I see the slides actually.
Okay.
You see it?
There appeared as a small icon next to the icon of the speakers in the lower part of the screen. Okay, Carles and Laurent as well. Pascal, did you receive the slides?
I'm seeing that the screen share is being started, but I don't see the screen share itself. It's kind of weird.
Yeah. Maybe on somewhere on the screen of
I granted Edgar, but go ahead, Edgar. I mean, if other people are saying it.
Okay. Okay. So basically, we did some changes or additions to the zero energy device draft, and basically what we have added was something related to more details about the delay-friendly optimized transmissions, also a bit of the architecture, how it could work, and also about the context configuration. So, for example, the fragmentation parameters, and then also a little bit about payload compression. So this presentation has some slides that I already presented, like for example, the different topologies. The one we are focusing mostly is the topology one, where the device is connected to the base station directly, at least at the moment. And then we want to mostly focus in device C and device B. So these devices are the most capable, and they have some kind of energy storage, so they could, in theory, produce transmissions and even amplify the transmission, so they could actually reach a macro base station. So this also I have presented before. So basically, what are the characteristics of this kind of devices? So they might have long delays, and they require overhead reduction because they don't have that much power for the transmissions. And then this is the first slide I want to discuss. The whole idea is that these devices, they produce certain kind of payload, which I will talk a little bit later. And then, but this payload most probably cannot be transmitted at once. So it can be that they have to segment it in several transmissions. And you never know when these transmissions are going to be finalized. So it's kind of unpredictable in some cases when the device will get energy to do the next transmission. Therefore, it's needed in the architecture that the operators could kind of catch this kind of packets so that they could, when the object or is finalized, can offer them to the applications or the application servers. So that could be done either by AP tunneling or by APIs or some sort of way of notifying, hey, now there is some data and you can fetch it. This is maybe one of the things what we try to explain a bit better. So the idea here is that we utilize SCHC as a transfer protocol. What does that mean? It means that instead of dividing a packet in fragments, we divide a full object in fragments. And then those fragments have some timers and have also a window and retransmission. And then this size of the tiles, they should fit to the sizes of the transfer format that these kind of devices can utilize. And the whole idea is that we can adjust the parameter according to the expected delays or patterns of that device. So how the device is expected to behave, then these kind of different parameters could be updated, also the window size. And then when finally all the packets are being transmitted, then there should be a notification, yeah, this whole object has finalized and we can then transfer it to the application. So this is one change with respect to how we use SCHC at the moment, because we are proposing to use it for the full object instead of using it for one packet. This would mean that you could also think about an object like a jumbo IP packet, of course. But yeah, the idea is that by using the characteristics of SCHC, we can actually achieve this kind of delay tolerance or delay friendliness towards the energy harvesting that is needed here. Then we were talking about this context configuration, and then there we were saying that there could be two possibilities, that there could be pre-configured already in some standard, some configurations that you only select. Maybe configuration number 1 has this kind of characteristics, number 2, and so on. Or it could be that the radio network, for the more capable devices, could send the characteristics of the context. So there are these two options, but For the more simpler devices, most probably this would be the option, the out-of-band configuration, and the more capable devices that even have compute maybe could have this second option. And now, what this mean? Well, first of all, we have to think about the delay expectancy. So how long do you expect that there could be a delay? So it could be that the expectancy is that there is no delay. So then that would be one type of configuration. Or could be that the delay is in hours, on days, on weeks, or even months. So then, based on that, then we would need to have different uh, values for the timers for the uh, packet transfer interval, the inactivity, also the retransmission, and also uh, depending of how big the packets are going to be transmitted, if they are small, medium, or large. And then, of course, this will affect the reliability as well. Yes, Lauren, you have a question or comment?
No, just a comment about the delays. So in the data model, we define a way to represent time that could be very, very short, but can be very, very long. So I don't think it's a problem here. Then there is an implementation dependent problem.
Yeah, what the idea of this delay expectancy is that we are thinking about, for example, this out of band configuration. So if we have something mapped to hours, for example, so you would think that maybe you will have retransmission timers that could be of maximum 6 hours and inactivity timer of 3 to 4 hours. So maybe this is something that could be used if something is using solar panels, for example. So you wouldn't expect that the device is working in the night and it won't work in the night, but during the day, maybe this would make um, sense. Or if there is something that the person is running and then is collecting energy from the movement. Then there is the case of a day. So it might be that it takes a full day for the device to recharge for sending a packet. Then it can be that this we are thinking about 4 to 7 days for having retransmission and inactivities of 2 or 3 days. And then we have the weak case, where maybe the idea is that the retransmission timer and activity timer could be quite close to the transmission time because you don't want to weeks. Hello?
I hear you, but I lost everybody else.
Same here.
Okay, I will.
Was cut.
Yes, there was a discontinuity, but I will do again.
Yeah, something happened with the server. Well, hopefully you hear me now.
I reloaded my page. I hope I'm not responsible for restarting all IETF.
Okay. I hope you heard the last thing I say. So about the retransmission and inactivity timer to be quite close to the transmission time. And then the same happened with the month. So these are so long periods that the values that we think they should be quite close. And then, of course, these are extreme cases that can happen still, that there are certain things that they don't receive enough power because they are on the ground, or they are, I don't know, in some location where they don't get energy to recharge. So those could be extreme cases, but maybe we want to consider them anyway. And then finally, the last thing we were adding to the draft was to reuse the same compression engine that is used in CHC, maybe also for the some payloads. So the idea is that if you have something like CNML, where you have certain values, you could actually compress quite a lot of it if we have a way to indicate that you are also compressing the payload. And we have been thinking that we could go this way, that many devices are going to be quite simple, and they are just sending certain values, and many times could be even the same value. Therefore, we could reuse the same compression engine for the payload, and then make it possible that with the same implementation, we could even reduce further the packet sizes by doing this kind of payload compression. So those were the updates we did. And then one question I would like to ask also to the group. What do you think would be good to also think about adopting this kind of draft and evolve it together so that we get it further, and then maybe utilizing TPP. I know that we have been studying SCHC use cases, and the SCHC has gained quite a lot of relevance. So starting with this ambient IoT or zero energy could be something that we could actually influence. Yes, go ahead, Pastor.
Yes, Edgar, I have two questions. First of all, before I ask my question, yes, I'm in favor of adopting a work like that as some form of best practice document that would explain how you can use SCHC for extreme low energy, extremely rare communication.
Yeah.
This being said, I was thinking out loud at what those communications are, because yes, you gave an example in 5G case, makes sense. I was wondering about delay tolerant networking in general.
Yeah. So,
When you're
like, for
going
example,
to
satellite
space,
or so
yeah,
on.
or even to the planets,
Yeah.
and when you're doing that, you might want to relay packet. And so I was wondering, because now at the moment we don't relay fragments. I was like, okay, do we need some work about relaying fragments? How that would occur?
Yeah, and that might be actually relevant for other topologies, like for example,
Yes, for
topology
intermediate
2.
load and topology 2 as something like that.
Yeah.
And
Yeah.
we don't have it right now in SCHC. I was like, oh, okay. So if it's purely a lower layer thing, then SCHC doesn't need to know. But is there something we could be doing, even if we impose some restrictions on the repeater? Is there some standard work that we would need, for those repeaters? It's just
Yeah.
something that I was thinking out loud
Uh,
at the time you were speaking.
Yeah, I think we have to maybe start with the simplest case of the direct communication, and maybe after that start to consider what happened with the intermediate nodes. But
But you agree with me, you're considering a best practice type of work at that point. When you're doing that, you don't change SCHC, right? You just
um,
provide it.
well, there are some changes that we are proposing, like for example, uh, that we can use SCHC for fragmenting a full object, unless we are saying that, well, we are saying that this is the same than a big packet. I don't know.
Yeah,
But
but SCHC is kind of transparent to what you're compressing, right? So if it's a big packet, quote unquote.
mhm, yeah, I understand. Well, as long as we can agree that that's the case, there is no problem. Um, and then the other thing is maybe about the packet sizes, and they could be different configurations. So this is mostly maybe context management. There could be different configuration because the same machine or the same device could have small packages or large packages, and maybe it might have different configuration if the packet is small or the packet is large. It might be that because it's large, it's gonna take days to transmit the whole packet. But if it's a small, it might take hours. So then the configuration might be different. So it's a little bit more in the how to configure this kind of things that in the SIG functionality itself. So maybe I agree with you that there is a bit like best practices in that sense. Yes, Lauren?
Yes, two question and a comment. Uh, do you target one fragmentation mechanism, or you all of them are possible?
What do
I mean, it's hack on error or it's no hack for?
I think we could have any, although for cellular, I think arc on error is the most suitable.
Okay, and so you know when you can send to the device, because if you send an acknowledgement to the device and the device is sleeping, then it will be lost.
Yeah, most probably the specification needs to have some way to communicate with the device when it knows that the device can receive. So that's something that has to be standardized because the device needs to be tracked. So
Hmm,
you need to know where it is.
okay.
So then there will be some kind of downlink capability. But then that will be most probably for the more capable devices, this B and C. I would even think that maybe even C mostly.
Okay. And do you see an interest for the FEC in fragmentation? Because we are starting working on that, and uh, it could be a way to secure your transmission without having to request what is missing.
Yeah, sure.
Mm.
Everything with fragmentation will be interesting.
Okay, and for the comment, I will contact you offline. But we had a PhD student that work in a compact way to represent NML, so I can send you some
Excellent.
information.
I'm really sorry, but we have to wrap
Excellent.
up.
Thanks.
So yes,
Yeah, Alex.
yes, thank you very much, Edgar. So yeah, I mean a lot of very interesting topics here. We are a little bit short of time, so I started a raise of hands. about your question to adopt as a working group item.
Mhm.
So we'll let that run for like, let's say, 2 minutes. I just wanted to add, so to join the comment from Pascal, that probably, this is heading to an informational type of document, or be, but informational in some sort. And I find it like very interesting in several aspects. Um, Probably what you can achieve with this document is to identify, like, okay, it will work like this, so that we can see, oh, okay, well, we're missing that piece, like we're missing that piece of
Mhm.
shit, and then we can do a very focused, like, standard track document. What do you how do you feel about this?
Yeah, sure. We can start like that, and we can see also how the 6G is evolving. As I say, we are starting to consider SCHC not only for these zero energy devices, but for other use cases. So it could be something that evolve even further. So that's okay.
Yes. I mean, definitely, and I mean, I really, personally, I like very much the work that you're doing with this document, and I think that it's an excellent way to drive, like, to get this topic in the working group. So that's great for me. And just one, probably a mini pointer. You remember that last time we discussed, that you presented the work. Juan Carlos said that in Wi-Fi there is like a similar kind
Yeah,
of activity that is starting.
yeah.
So maybe you would like, maybe you can, like, ping him and see, hey, well, is it something that is close? So in
Mhm.
which there could be only one document, or is there sufficient differences so that I mean, just to see if he's interested in contributing in some way.
Sure,
But
that sounds good.
it's really very timely and very, very interesting work for me personally. Um, so with this being said, so I'm going to terminate the show of hands. So we have 9 people voted for, and none against, and none with no opinion. So at least for me, in this during this meeting, everything is like, good. It's adopted, but of course we'll need to confirm that on the mailing list.
In the mailing list. Yeah,
And for the moment, of course, we're heading for an informational track. Um, document.
excellent. Thank you. Thank you, everyone.
Yes, thank you. Oh,
Edgar, yeah,
yes.
I'm sorry. Do you want to publish some update before we do the official call for adoption on the mailing list? Or do you want, in which form do you want, what document do you want us to use?
Um, I will have to check the if something let's say very important is still missing, and then I can reply to you. At the moment, I don't
Yes, so
recall.
please send us an email offline to the chairs to tell us that you
Yeah.
want to make an additional publication before we do the call. Here,
Okay.
clearly, the intention of the working group is to adopt, but the actual content, people will have to check it on the web. And
But
so
I
please let us
think
know
the
when you're
current
ready.
content is good enough to start the adoption, in my opinion. And then if there is some feedback or comments, we can consider them, and if needed, then we can do a new version. But I think with the current version, it's okay to start the adoption, and then we need to work further. For example, if we want to establish some specific configurations like we were talking about and things like that.
Yeah, I asked the question because we discussed the need for relays. We discussed whether it's
Mm,
informational or not informational.
yeah.
And so it's better to adopt a document which has close to the type of content that we want the final document to have. So
Yeah.
if you're very clear that you don't want relays so far, or if you're really clear that you want relays so far.
Yeah, I think for the time being, relays are not being considered even in the standardization. So I wouldn't, in 3PP, so I wouldn't start from there at the moment.
Okay. So if you're happy with the current document to call for adoption, we can do that.
Yeah, I think maybe some format corrections could be done because it haven't.
I'm more concerned with the scope of the document than the orthograph or something.
Yeah.
It's like,
Okay.
Or we can just shoot it up, and then we'll confirm on the mailing list, and then we'll change after.
Excellent. Thank you.
Yes, sure. Thanks, Edgar and Jaime. Really sorry, we're a little bit behind, so the floor is yours.
Thank you.
Let me
Will you share the screen, or should I?
Go ahead if you can.
Okay, just a second. Okay, perfect. So you're sharing. So I'm going to be presenting about a concept that I have developed in the last IETF in the hackathon of using the byte pair encoder tokenizer, the ones you have in common LLMs, for compression of arbitrary strings. Yes, thank you for the control. So there is a Git repo with the code. I have not yet shared. I will work on that. But for now, I can give you some of the results and a bit of the general point of what I'm trying to do. So just for context, you may have used LLMs recently. I mean, there is the well-known GPT-4, there is Llama, there is a million other Mixtral, and so on. There's many. They use a process called tokenization. Tokenization is an independent process from the LLM. It has its own, so the tokenizer has its own training data set of text, which will be different than that of the LLM. It will be much smaller, of course. And the point of the tokenizer is to translate back and forth between raw text or strings and sequence of tokens. And the LLM later only ever sees the tokens and never deals with any text directly. So, for example, there you have using the well-known GPT-4 tokenizer. There is a million tokenizer. There is many. You can see how the encoding of the hello world text looks like in 4 tokens. So the different tokenizers have different vocabulary sizes. They have different encoding schemes. I'm using byte pair encoding, but there's others. And each tokenizer is optimized for compatibility with a specific model. So there's a lot of manual testing, at least to my knowledge, manual testing and optimizing depending on the use case. So next page. So what I'm trying to do here is for CBOR has a bit of a limitation, which is that the arbitrary strings are not really subject to compression. So if you have addresses or you have keyboard inputs or arbitrary strings, normally you just send it as it is. So this would be like a new general purpose solution for arbitrary strings. Is not a map, is a vocabulary that needs to be shared between the 2 endpoints, but that you can run for any string. And the vocabulary in my test didn't have to be too big. 30 kilobytes actually, already yielded some degree of compression. Another nice feature, I think Carsten mentioned that, is that you can do a string pattern matching of the tokenized string. So when you have the 2 tokenized strings, you can compare them, providing again that you have the same vocabulary. And it works also on strings that are not, I mean, it obviously works on new strings that are not used for the vocabulary training. So if you have new, let's say you receive strings in other languages or in other kind of strings that maybe have similar tokens, you will reach some degree of compression. And then this means that if can you hear me? Sorry, I lost connection for a moment.
Yes, you're back.
Yes.
Okay. Did you hear the string pattern matching, or was it cut short earlier? Sorry about that.
Yes, it's okay. It's okay.
Okay, perfect. So
just the micro stuff.
All right. So basically, yeah, as I said, like it works on new strings that were not part of the vocabulary training. So okay, it doesn't. I lost the control of. Now it came back. Sorry. No, it didn't. I lost control of the slides. Let's close the deck. Can you share it again?
I took control. I'll change the slides for you.
Thank you.
Yeah. Is it this where you want to be?
Next.
Implementation. Is it okay here? Hello, can you hear me?
One less, please. There's some weird connection issues, apparently. I don't know if it is just me.
No, it's not just you. I mean, we all experienced it earlier.
So let's do a slide 4, please. So let's say that in an example, you have there some address, arbitrary address that the device is sending. Then the tokenized version would look like an array of those integers based on a vocabulary of, let's say, it looks like 4,000 tokens roughly, or 3,500 tokens roughly. So next slide. What do I have in my implementation? So I was using min BPE, minimum bypass encoding Python library, pretty useful. The CBOR 2 for encoding and decoding. Needless to say, I do first CBOR, and then of the CBOR, the remaining strings, I think it's I forgot the term, but the type 3 strings are the ones that are tokenized. And then for the vocabulary, I was kind of trying to cheat, but I was not very successful. I was using Broadly dictionary and RFCs as training test, but you could use other. I think it can be optimized greatly, the vocabulary, but still. Anyway, that's what I had for now for the vocabulary training aspects. So basically, what you have there in the screen, the code, it shows you the training phase in which you are checking the occurrences, and you are seeing which are the tokens that are the most common, and then basically you take the ones that are the most common, and then that's your vocabulary. Next slide. So, for example, on let's say that you have this type of JSON, you could, so the tokenizer would not affect common. First of all, it wouldn't affect integer values because they're already optimized, or float values. It wouldn't affect mapped parameters. So if you have already your own mapping function from temperature to value 1, from humidity to value 2, or whatever, there is no point. That's already very compressed. But for instance, if you have something like URNs with common patterns that can be tokenized, or names or addresses or things in different languages or timestamps, those could be suitable for tokenization. Next slide. And then on the results, basically, yeah, as a disclaimer, I was using synthetic data. It's not that easy to come by with big data sets of IoT-related payloads. For some reason, I couldn't find many. I found some databases for somewhat related strings, like those of Uber vehicles with location information, or that type of stuff. I couldn't find better synthetic data, better real data. So I was also using synthetic data model based on lightweight M2M schema. And yeah, basically what I achieved, it was about 20-30% data compression from the original CBOR compression. So basically compressing only the strings. And then another thing that this enables, by the way, I mean, is that once you have everything tokenized, you can run inference on the receiving end, because at the end of the day, LLMs consume tokens. On the next slide, there is a graph of the values that as they were compressed. So you have the CBOR length in red, and the tokenized, the total tokenized length in purple, which is right below. Yeah, I mean, nothing surprising there. Basically, the the total string length is longer than the tokenized length, as is to be expected. And yeah, I mean, I did run also larger tests, but I mean, actually, one thing that could be useful is to get my hands on real data that has strings and all that. So that will be very convenient, by the way. But next slide, please. As food for thought, basically, you can achieve a certain degree of compression by default on arbitrary strings, so that's pretty nice. And then, of course, it's not, if what you're targeting is hardcore compression, then you will run multiple cycles of byte pair encoding, but then you cannot do a string manipulation. Then another trade-off would be the hardware requirements of the endpoint. They are not, so again, providing that you have the vocabulary, running this tokenizer is not expensive, but of course, training the vocabulary is expensive, but you can do that in another endpoint. So ideally, you run them in your system, you create the vocabulary, do it in your system, and deploy it, and send these 30 kilobytes once every now and then, and share the same vocabulary among all of the endpoints. And then, yeah, the vocabulary size and the size of the input string. So depending on the vocabulary size, you can achieve much better compression at the cost, of course, of requiring more memory. Yeah, and then for future work, basically, like, I haven't explored too much the running inference on the receiving endpoint, but I think it has a lot of potential as well. Then optimizing the vocabularies, I already mentioned, like it was a best effort. And the input training test, as I said, like I was lacking a little bit on that side as well due to the synthetic data. If there was a really good data set for IoT data for strings, I could use that both for the vocabulary and then for the compression, and then try also with new training sets afterwards. And then I think it's just references. The next slide, please. No, yeah. So first, yeah, sorry, before that. So I don't know. I mean, this was an exercise in the hackathon, just to see if this works and to try to see if this is something. I don't know where it fits in the IETF. I mean, you need a vocabulary shared between the different endpoints for this to work. So that would be a requirement, the main requirement, really. And I don't know if anybody has explored this already, or, I mean, I'm not inventing byte pair encoding. That has been done for a long time. But in the context of compression, I don't know if it has been used in this way in SCHC or in other places. So I will welcome feedback or thoughts. And if you could maybe one more than, yeah, sorry, go ahead, Alex.
No. Thank you very much, Jaime. So as we are a little bit behind of time, so I love your work. I find it super interesting. Just if anyone has one question for. So okay, I'm keeping the floor then. So yes, it's like mostly on observation. And yes, I think that, as you said, it's really important to see where we get the data to train these dictionaries, like these shared tokenized dictionaries, and to see also how the compression rate varies with the size of the dictionary and like the compute power that's necessary on the end device. So that would be really useful thing, I think, because then we can see if there are use cases. What are the use cases for that, right? And yes, Laurent said that both you and Edgar, you're talking about payload compression.
Yeah.
So probably we should yes, add this to the architecture document as a way. How do we address that? But yes, so I found this really interesting work, and let's get back to on the mailing list about, and I would really like to rediscuss that one, on a time that we have a little bit more time.
Sure. I mean, if anybody has comments or thoughts, please contact me over Telegram, WhatsApp, and just be blunt. Like if this is nonsense, just tell me, Jaime, what the hell are you doing? And if this could be something, also be equally blunt. I mean, I'm just curious to know how far can this go and whether it's useful enough. I understand that for those who are hardcore into compression, maybe it's not so useful, but for general purpose, general compression mechanism, this could be good. Thank you for the time.
Yes, of course, with biggest pleasure. And thank you for the presentation. So we are a little bit behind of time, quite a lot. So Carles, are you presenting or is Anna presenting?
Hello.
Hello. Yes.
So yeah, well, I will present the first slides, and I will present some of the last ones.
Okay.
So yeah,
So
I see.
just one point. If you would like to have like time for discussion, maybe we can also consider putting part of the discussion, like part of the slides for the next time, because I know that you have like a very big important presentation. So take your time, and the next time we'll continue.
Okay, yeah, makes sense. Thank you. Okay, so this presentation is about some of the thoughts that we have, Anna and me. We are trying to think about how our 6-law draft, which is about transmission of SCHC compressed packets over 15.4 networks, would need to be aligned in order to be like synchronized with the SCHC architecture draft, especially after the last update of the SCHC architecture with concepts such as the SCHC header and related concepts. So, well, I'll be a bit faster, but basically, well, the main incentive behind the 6-law document is trying to use SCHC as header compression mechanism as an alternative to 6-law PAN traditional header compression over 15.4. And now, however, there's the SCHC header concept, which has been really developed in the last update of the SCHC architecture draft. So for 6-law, we would like to keep this SCHC header fully compressed only, well, that's only if possible, otherwise, well, contributing as low header overhead as possible. So as you may recall, the main problem we have in the 6-law draft is multi-hop communication. So sending SCHC compressed packets in a multi-hop scenario. So for that, there's route over, and there's also mesh ender. And for route over, we have 3 modes in the document, straightforward, which means that all nodes, well, all the intermediate nodes, the routers have all the rules that are being used in the network. However, this has issues in terms of scalability. Then in order to avoid that, we have 2 other modes, tunnel-based, which exploits if you are using Ripple. Then there can be a tunnel from a source up to the root, and then from the root, if the destination is internal to the 6-law PAN network, then there's another tunnel downward. And an alternative is pointer-based approach, where there is a pointer which is prepended to the SCHC compressed packet, and the pointer will tell any intermediate node how to find the residue of the compressed IPv6 destination address, so that the router, even if it doesn't store the rules, it can still determine and reconstruct which is the IPv6 destination address in the packet. So, okay, from here, there are some concepts we've been thinking about. And first of all, we understand that there could be like 2 possible network types. One of them is what we call single instance networks, where all devices in the network would use a single SCHC packet instance. And in this case, what we plan to require in the document is that the SCHC header, in this case, must be fully compressed. And then there's another case here in red, multiple instance networks, where at least some devices in the network use more than one SCHC packet instance. Here we understand that the SCHC header cannot be fully compressed, and this has been like the main object of our discussions. So here we have some example networks and how this multiple instance concept would be, and the fact that we actually need the SCHC header, which cannot be fully compressed. By the way, in the box at the right, when you see that it's not compressed, it should say it's not fully compressed, okay? So here we have an example. This is in TRO tunnel-based approach. So let's imagine that host A transmits a SCHC compressed packet up to the 6LBR, who would be a Ripple root. And let's assume that it's using rule ID 2 to compress the packet. Then, well, you can see also that there are several rules being used here with several rule IDs, and you see 2 colors. So black means one SCHC packet instance, blue means another SCHC packet instance. Each instance would have its corresponding set of rules. So when the 6LBR receives a SCHC compressed packet with rule ID 2, then the question is, okay, which one of the instances is the one that needs to be used? The black one, the blue one. So for this, we need this SCHC header, which cannot be fully compressed. And in the other direction, it would be a similar problem. So if host A receives a SCHC compressed packet with rule ID 2, then it needs some not fully compressed SCHC header to be able to determine whether it's the black rule ID 2 or the blue rule ID 2 that has been used. So this is an example for TRO. Then for pointer-based or PRO, something similar may happen. In this case, it's not necessary to go through the route. Imagine that host D transmits a packet to host A. And well, in this case, if host A receives a SCHC compressed packet with rule ID 2, then there would be a similar problem. Okay, which is the rule that needs to be used, the black one or the blue one? So for that, we need this not fully compressed SCHC header. And in straightforward, where, as you can see, the intermediate routers would need to store the rules being used, well, something similar happens as well. Here, host A would transmit to its next hop, which would be the 6LR on top. And then if the SCHC compressed packet carries rule ID 2, again, there's the same problem. Which one is it, the blue, the black one? And for that, we need a SCHC header, which is or cannot be fully compressed. And also, this is a special case because in the straightforward scenario, this would work as long as there is some means that make sure that there is some parameter in the SCHC header, maybe session ID or whatever, which has to be unique network-wide. Otherwise, this might not always work. So finally, there's mesh under. So here, by the way, there's the issue in the slide that, well, there is no 6LRs in mesh under, but this would be mesh under forwarders. But anyway, imagine that host D transmits a packet to host A, then the packet is routed by mesh under, it reaches host A, and a similar problem might happen. So if we look at the details of the example, it might seem that, for instance, if host A receives a packet with rule ID 2, then it might be possible to say, okay, if the sender is C, it's the black rule. If you look at the information on the right, on the legend, and if it's it's D, if the source is D, then it's the blue rule. And well, this is something that could be used because in the mesh header, there's the information of who is the origin of the packet. However, then there might be ambiguity as well if in some case there could be two rules corresponding to different sets of rules and for communication between the same two endpoints. So even in that case, we might need a not fully compressed SCHC header. So then the formats would need to be updated, the formats that we have in the draft, because now we have to introduce the presence of the SCHC header. So this is one example for TRO, tunnel-based. So as you can see with red, there's the SCHC header, which would be prepended, would appear before the SCHC packet. And here the point is that in some scenarios, this could be fully compressed. The SCHC header would require the transmission of 0 bits over the air, but in others, as we've seen, there would be some bits that would need to be transmitted. In the case of pointer-based, well, this is the PRO header. This is the header that is prepended to the SCHC compressed packet, which includes the bit pointer to discover the compression residue of the IPv6 destination address. And here, the natural thing would probably be that after the PRO header, there would be the SCHC header and then the SCHC compressed packet. However, as you can see, we are considering to locate the SCHC header like in the middle of the PRO header. And that's because somehow we felt like this could simplify a bit or keep more simple the definition or the behavior of the bit pointer. The bit pointer states after the end of the address length, how many bits do we have to count to find the start of the compression residues. And however, we thought that this is maybe a simple way to do it. And well, maybe more natural, again, here in straightforward route over, we would have a SCHC header before the SCHC packet. Again, in some cases, fully compressed, in some others, maybe not. So we believe that in the draft, in the 6.0 document, we may need to add some section discussing specifically the SCHC architecture concepts, how they apply in 15.4 networks. And we understand that there are the two possible scenarios that we were mentioning: single instance networks where the SCHC header is fully compressed. Then we understand there's this one SCHC header instance, which is minimal, which contains like a single implicit rule that all nodes know, similar to what we were doing in LP1 recently. And then there's only one SCHC packet instance, therefore it has its corresponding set of rules. Then maybe one question might be, what is the discriminator here? So we think that perhaps it could be the SCHC dispatch, or in the case of the pointer-based approach, the SCHC pointer dispatch, because it's like the first field in the 15.4 frame payload, which tells that what comes next is compressed by means of SCHC. And parallel to that, there would be like another section for multiple instance networks. So here, there's for the SCHC header, it is that it cannot be fully compressed, as we've seen before. Then for the SCHC header instance, there would be one set of rules, which might comprise maybe more than one rule if necessary. There would be several packet instances, each one with its corresponding set of rules. And again, for the discriminator, we believe that the same applies, that perhaps it should be the SCHC dispatch or SCHC pointer dispatch. Then I guess that maybe Anna can continue, or I can browse the slides for her, if there's still.
So I mean, we're like 2 minutes behind the time. Would it be okay for you two to like maybe just have like a 1 or 2 minutes for questions, and then start again with your presentation next time? Because I find it like very fundamental for what we're doing, and it would be really nice to have the time to really go into it.
Yeah, sure.
So I don't know, Anna, do you have anything to add? Like a very, very rapid thing?
Well, the next slide was about the transition protocol and how we can define a way to know that after the IP header compressed by the 6282, we have the SCHC compressed by UDP and co-op header. And the next slides gives the SCHC header for describing the UDP next header and the co-op port to know that the next header is not only SCHC, but you have an UDP and you have co-op after. And the rule that we may use to compress this SCHC header.
Okay. So what I suggest...
I guess we need to rediscuss that next time. I mean,
yes.
Yeah.
So let's do it correctly next time.
Yes,
and just
because here we have some points to discuss about the session ID and how we can, if we really need it or not. Yes, we need to discuss more in detail.
Yeah, I mean, it's really, and probably actually it's quite good like this, because we have like a rapid overview, and then we'll have like the time also to get again over the slides and actually really discuss them. So probably I would suggest that we stop here.
At least what we want to do is to use all the new version of the architecture and to apply it to the 6LoWPAN solution and see the different points.
Yeah.
That was the idea of this new version.
Yeah, I mean, it really looks like an amazing work, right? It's and it's very like there is a lot of things for us to discuss, like a lot of questions, and so thank you both. Thank you, Anna. Thank you, Carlos, for actually doing all that work, because it's like a very like I have a lot of questions in my mind and a lot of things to say. So it's very exciting times as well. So I'd suggest that we stop here. Sorry everyone for like having for ending like 5 minutes behind the time. Thank you everyone for being here. Thank you, Marco, for taking all the notes. I mean, there everyone participated, but I saw Marco taking a lot of the notes, so thank you a lot. And see you in 2 weeks' time. Bye, everyone.
Thank you all.
Thank you. Bye.
Bye-bye.
Thank you. Bye bye.
Bye.